Okay, so this next example asks us to find the equation of a tangent line. To the graph of this function here, we've got y equals 3x squared plus 9x minus 1 at this point, which is given to us with x coordinate 2 and y coordinate 29. Okay, so how are we going to do it? Well, first of all, what do you need to get the equation of a line? You need the slope, and you need a point that the line goes through. Right, so let's start with the slope, and the slope is given to us by the derivative. So let's start by computing the derivative of this function. So I'll start by computing y prime. That's the first step. So y prime, we're just going to do the power rule on each of these three terms. Right? So the first term, I'll just put the 3 down to the side, and then I'll do the power rule on x squared. The derivative of x squared, based on the power rule, is going to be 2x to the 1. And then the derivative of 9x, that's going to be 9. Right? So we've already had plenty of practice with derivatives now. So this just follows from the work we've already done, and then the minus 1 is a constant, so the derivative of that is going to be 0. So I can go subtract 0 just to be complete. Just to make sure we've checked all three terms, right? Okay, and if you clean this up a little bit, you're going to get 6x plus 9. So that's your derivative. But we want the slope of the tangent line to this graph at a particular point. And this is not a slope, right? This is a function of x. A common error at this stage of a problem like this is people will take this expression here and try to use this as the slope. But slopes are fixed numbers. Slopes are not dependent on x, right? They need to be fixed numbers. And the way to turn this into a number is to plug in the x coordinate of the point that you're given. That's what's going to give you an actual slope. So there's our slope, and I'll just call it m because we usually use the letter m for slope. So the slope is going to be given by the derivative of the function y at the particular point x equals 2. So really, just take this expression and plug in x equals 2. So we're going to have 6 times 2 plus 9, which works out to be 21, right? 12 plus 9. Okay, great. That's our slope. And just a reminder, this was reminded to you on the lab worksheet, but the formula for the point slope form of a line is y minus y naught is equal to m times x minus x naught, where m is the slope and x naught, y naught are the coordinates of a point that a line goes through. So this is just so I can make sure my reminder here is complete. This is point slope form of the equation of a line. I'll just write this though. Okay, so well that means we're almost done because the tangent line then, we have everything we need. The tangent line is given by, so we'll have y minus y naught, or y naught's going to be 29. And then our m, we worked it out, it's 21. And then our x naught is going to be the x coordinate of that point, so it'll be x minus 2. So that is the equation of our line. You could certainly write this line down in other forms. You could write it down in slope-intercept form if you like, and that's totally fine as well. There's nothing stopping you from doing that. But I think point-slope form is easier, given the fact that we have a point on the line already. Okay, so that's that example. In the next example, we are asked to find the points on the curve or the graph of this function y equals x to the 4 minus 6x squared plus 4, where the tangent line is horizontal. So what does that mean exactly? Well, think about this sort of a situation. Imagine the graph looks like this. I just made this picture up. This is not the actual graph of the function in the question, right? But you could imagine you could have a graph like this. So what does it mean to ask when the tangent lines are horizontal? We're talking about places like this. Right? At these 2 points, in this case, with this picture, this is what it would look like. Those are the places where the tangent lines are horizontal. Because if I draw the tangent line, well, what else can you say, right? The tangent line is literally horizontal. That's what it means to be horizontal. It means to be flat. So what are the slopes of those lines? What are the slopes of horizontal lines? Their slopes are 0. So that's how we're going to attack this. We want to find when does the slope of the tangent line to this graph, or to the graph of this function, have a slope of 0. So let's just compute the derivative as a function of x and figure out which x values make that derivative 0. So we'll start with the derivative just like we did in the previous problem. So to take the derivative of each of these terms, so x to the 4, do the power rule on x to the 4 and you're going to get 4x cubed. Then we'll have minus 6 times, and then use the power rule on x squared and you'll get 2x, and I won't even write 2x to the 1 like I did last time, right? Because that 1's not going to do anything. So the derivative of x squared, from now on I'm just going to write 2x. Right? Up here I wrote 2x to the 1, but that, like I said, that 1 doesn't do anything. It just turns into an x. So that just became 6x. So from now on I'll just write 2x. Okay, and then the plus 4, that's a constant, so that'll be 0. If you take its derivative, again, I won't write the plus 0. I won't do that anymore. It's not necessary. So, okay, so what do we get? We get 4x cubed minus 12x. So that's your derivative. So what you want is you want y prime to be 0. So it's going to come down to solving this equation. Let's solve the equation 4x cubed minus 12x is equal to 0. Okay, and it helps to factor it. Factor the left-hand side. So you can actually, there's a common factor of 4x on the left-hand side of this equation. You'll get 4x times x squared minus 3 is equal to 0. And that's going to be, that'll work when either 4x is equal to 0 or x squared minus 3 is equal to 0. So solve each of these equations separately and we'll get all the solutions to this equation. So the first one's easy. Just divide both sides by 4 and you get x equals 0. But over here, just solve for x carefully. So bring the 3 over. This is one way to do it. You get x squared is equal to 3. And then if you take the square root of both sides, you're going to get x is equal to plus or minus the square root of 3. So those, I'm going to just box them in green here because they're not our final answer. But we're going to use them to get our final answer. We're almost done, right? The rest is just a formality because these are the x values of the points on the curve where the tangent line is horizontal. But we want the actual points on the curve. And technically points have y coordinates as well. So we should actually write our answers down that actually in a form that supplies the y coordinates as well. And we can get those by just plugging these x coordinates back into the original function. But make sure we plug them into the original function. We don't want to plug them into y prime. We know what we're going to get. If we plug them into y prime, we're going to get 0 because that's how we found those values. But let's plug them into the actual function. Okay, so if I plug, let's start with x equals 0. If I take the value of y when x is equal to 0, well, that's going to be just 0 to the 4 minus 6 times 0 squared plus 4, so that'll just be 4. So that gives us 1 point. Let's write the point down over here. So one of our points has an x coordinate of 0 and a y coordinate of 4. So that's 1 point. Okay, what about the value of y when x is equal to root 3? Okay, so we'll have root 3 raised to the 4 minus 6 times root 3 squared plus 4. So what will that give us? We'll have root 3 raised to the 4. That's really just 3 squared, which is going to give us 9. And the square root of 3 squared, that's going to, the square and the square root cancel out and give you 3. So you've got 6 times 3, so that's going to be 9 minus 18 plus 4. So you actually have 9 minus 18 plus 4, that's going to be negative 5. Okay, so that means we got another point. Root 3, negative 5. That's another point where the tangent line is horizontal. Let's get the last point. So y when x is equal to negative root 3. That's the last point we want. So we're going to have negative root 3 raised to the 4 minus 6 times negative root 3 squared plus 4. So actually, this is going to work out to be exactly the same, right? Because negative root 3, it's going to be the same as root 3 when you raise it to the power of 4, because that negative is going to disappear because you're raising it to an even power. And same with over here. Root 3 squared was 3. Same with negative root 3 squared, right? That's going to give us 3 as well. So what you end up getting here is, again, you get 9 minus 18 plus 4, which is negative 5. So then to finish our last point we have negative root 3, negative 5, these are the points where the tangent line, or tangent lines really, because there's a tangent line at each point, are horizontal. Okay, so that is how you can find horizontal tangent lines, which is actually an interesting problem in calculus and has lots of applications to real-world problems, which we'll soon see. But for the moment, that's your process. If you want to find horizontal tangent lines, just take the derivative and figure out when it's 0. This is really the key step here, setting the derivative equal to 0. Okay, so that is that example.